Hello. Hello and welcome to this video. In this video, we will look at the example of heapq in the standard library of Python. So if you have watched my data structures video of C programming, then you would know how to implement mix heap and man heap. And this is just the Python version of that one only. Although some code in this one is extra, which is not covered in min heap and max heap. So let's get started. In the last video, we have seen all these functionality. So we have a list of numbers, okay, and we print the original list. Then we call heapify on that list, and after heapify, we have the heap list which is heapified, and the smallest number will be the first element of the list. So let's take a look at this in action. So this would be heapq example, Python space heapq example. So original list is this one, and after heapify, it became this, and smallest element is 10. So how do you read this? 10 has the child 20 and 70. 20 has children 30 and 40, and 70 has 90 and 80. 90 and 80. That is how you figure this out. Okay. So we comment this out. We don't use this. And then we look at this. Okay, we need numbers. All right. We need the list numbers. Okay. All right. So we need numbers till where? Let it be there. Let's look at the entire example and then we will run this. It is not very complicated. Then we have the heap push example. So we push numbers 5 and 15, and then we look at the numbers. So we push numbers 5 and 15 to the numbers list, which was heapified for us. Then we have heap pop. We do the heap pop. So this should give us 5 because 5 is the smallest element. Then we have, so we take a look up till here. Okay. We take a look up till here. Okay. Let me comment this out. So we have numbers, we heapify, then we do heap push, and we have the smallest, and then we remove, we do heap pop again, and that should give us something. Okay. So we run this, and we push 5 and 15. So they arrive this way, and then we do heap pop, then 5 is removed. Okay. And remaining numbers are rearranged. So that is how it worked. Now let's comment this from here to here. Okay. Now we comment this out. Now we have another heap 10, 20, 30, 40, and we call heapify on this. And after that, we will have some heap, and then we do push pop. Okay. So we are pushing 25, and 10 will be pop because 10 is the smallest element. All right. So we look at this, and 10 is popped, and the heap after that is 20, 25, 30, and 40. So we comment this out now, and we comment till here. Okay. So we have again heap of 10, 20, 30, 40, and we call heap replace. So when we replace, smallest element will be taken out, 10 will be taken out, and the heap will have remaining elements. So again 10 is taken out, and the heap is similar like push pop. Okay, so we take this out and we comment till here, and then we are looking at two functions. One is m smallest, another is m largest. So we in the heap we have 45, 12, 78, 2, 90, 17, and 4. And three smallest numbers would be 2, 4, and 12. So we will get 2, 4, and 12. And if we want n three largest, then those would be 90, 78, and 45. So let's take a look at this. So as expected, 2, 4, 12 are the three smallest numbers, and 90, 78, and 45 are three smallest numbers. So we comment this out, and then we have merge. So suppose we have three lists. List A having elements 1, 4, and 7. List B having element 2, 3, 8. And 5, 6, 9 is the third one. And we call merge on these three lists. So we will get one list which will be merged, which we are printing as merged list. Okay. So merged list will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we comment this out, and we are looking at priority queue. So suppose we have priority queue, which is an empty list. We push to this list 2 comma write documentation, 5 comma watch movie, 1 comma fix production bug, 3 comma answer emails. So see, if we traverse this priority queue and pop the elements one by one and you print priority and task, then 1 will be the smallest element which will come out first, then 2, then 3, and then 5. Okay. 1, 2, 3, 5, they came in that order. Now we comment this out, and we look at table priority queue. So in this, we are making use of iter tool counts, okay, which with which we implement a stable priority queue. So here we have not studied iter tool counters yet, but here the value of next counter will start from 0, then 1, then 2. And when you pop, they will come out in that order only, okay, because the first key is same for all of those. So they came out in that order. Okay. Now we look at updating priorities. This one is a bit longer. Okay. So we understand it one by one slowly. So we have a removed string, which is remove task, and then we have a priority queue, empty list, entry finder is a dictionary, and counter is iter_tools.count. Now add task. This is a task and priority. So we don't know what is task and what is priority. We will have to look at that. So tasks are strings, task A, task B, task C, and priority is 5 to 8. Okay. So that's what. Now, in the beginning, the task won't be in the entry finder. So we don't remove it. Then what happens is we construct entry. Entry contains priority. Next counter would be 0 to start with, and then the task. Okay. And in the entry finder, against the task, we create an entry. All right. And then in the heap queue, we push this in the PQ, the entire entry. Okay. Now let's see what we do. Then we do pop task. So if we do pop task, task B should be popped. Okay. It has the list number and so many. Then we say task C and we add 1. So 1 should be added. So at this moment, there are 3 tasks in the PQ. That is 1, 5, and 8. And while true, we pop task. Now in the pop task, what we do a heap pop. So priority and task will come out. So first it should be 1 comma task C. Okay. And task is not in the remove. If task is not equal to remove, we delete entry finder task. So from the entry finder, we remove the task and we return the priority and task. So what should it contain now? The first, it should be 1 comma task C, and then 2 was removed earlier, then it should be 5, and then it should be 8. Okay. Okay, let me see if I commented this. So that is how it should work. Remove task, did we encounter remove task? Remove task. No, okay, remove task is here. All right. Now let me see. Okay, looks good to me. You see, it updated the priority of the tasks. So task C was initially 8, which was updated with task 1. So my understanding was a bit wrong there. So initially it would be 258, and then we see pop task. So pop task should do what? It should delete all the, we call it once, right? So if we call it once, hang on, let me see. Okay, so these are the functions. So first we add tasks with 5, 2, and 8 priorities. Then we print and then we call pop tasks. So since we have done pop task, all these should come out. And then we do add task C. So task C is the key and priority is updated. So it should become 5 to 1. And then we do pop task. Okay. So when we do pop task, it should come out from the PQ. Let me do a quick check here. Print list PQ after pop task. Let's see what it contains. Okay. We shall. So 50 task A. So it contains 50 task A and 82 task C. 82 task C. 50 task A, 82 task C. So while adding, the counter with 5 would be 0, counter with 2 would be 1, and counter with C would be 2. So yes, at that moment, that is correct. So pop task printed, no, sorry. So pop task printed 2 task A, B, that was correct. Okay, my understanding was it was include, that was incorrect. This add task updates the priority of this one. So why I made that mistake is it is add task C, and if you see this task would be already in entry finder. Okay, so it will call remove task, and then from the entry finder that task is popped and it is removed. After that, what will happen is entry will construct new priority, that would be 1, and counter will be next one, next counter, and task. So what this will do is this will create a task C with the next counter. So if you see this, the counter will become 3 now. It should become 3, from my opinion, for task C, because a new call of next counter is made. Okay. So you see with task C, we have a new counter 3 and 2 is removed now. Okay. So that part of understanding was wrong. So it will update the task. Okay. So now we comment this out and we move on to scheduling example. Okay. Why this is commented out? Okay, it is here. All right. So we have a scheduler example. So we have heap queue, we heap push events. Events is an empty list, and we push 15 coffee, 9 meeting, 20 dinner, 12 lunch. So obviously it will come out in the order of 9, 12, 15, and 20. Python space. So as expected, it came out as 9, 12, 15, and 20. So nothing complicated about that. And then we remove this. And then we look at top k largest elements and top k smallest elements. Okay. So in this one, the top four largest elements would be 91, followed by 88, followed by 67 and 43. 91, 88, 67 and 43. And smallest should be 7, 10, 19 and 21. So as expected, we have the results. Now let's move on to next one. It's a max heap example. So how do you implement a max heap using the heapq? So if heapq has an attribute heapify max, we call heapify underscore max on the data, and we print the data that would be the max version. As you remember, all the functions have max suffix for max heap, and that is how it works. Okay. If this property is not there, then max heap requires Python 3.14 or newer. So that's what we will have. So with this, I will end this video here. I hope that you got a fair bit of idea that how heapq works in Python. And there is a simulation of max heap in older Python, which I really don't care about older Python. But I would like to show you just for the sake of completeness. So if you are on older Python other than 3.18.4, what you do is suppose you have a heap and you have elements in this, then you push minus x. So these will be negative values. So that's why they will be coming out in the reverse order. And while popping, you put another negative or unary minus operator, which will make the item plus. So for the sake of completeness, let's see this. So that's here, the max heap example. Now the complexity, most of it was discussed when we were doing the third discussion. Certify is order n, heap push is order log n, heap pop is order log n, heap push pop is order log n, heap replace is order log n, and n largest is n log k, n smallest is also n log k, and merge is order n log n. Okay. So these are the complexity, and I will put this entire code as a gist, and the link of that gist will be there in the description. All right. So this entire code I will put as a gist, and you can read this code from the gist from the description of the video. So with this, I will end this video here, and we will meet after 4 days again with the next item in Python documentation. Let's see docs.python.org. Let's see what is there next. So after heapq, what do we have? Array bisection algorithm is what we will study next. So let's see how big it is. It should be covered in one video. It's not too much, and we should be able to see the example also in one video only. Example and theory both can be covered in one video. So with this, I will take my leave, and we will meet again on the 4th day, most probably. And so thanks a lot for watching the video. I hope that you enjoyed it. So keep learning, stay curious, and most importantly, enjoy.